Hello and welcome everyone to our today's PointSense for Revit What is New session for introducing you the latest software version we have just released in October this year. It's the version 17.5. Wherever you may join to this event at the moment, we are glad you have found time to participate, and I hope you will learn interesting new stuff here in our call today. This webinar intends to inform you on the latest features in our powerful laser scanning plugin software for Autodesk Revit. And with me today is my colleague Christopher Palmer. Christopher is our sales expert in the UK, and Chris owns a very profound knowledge of Revit and our PointSense specific Revit plugin. And I'm happy to have him in the call today to get you the latest features presented. Some hints for this meeting before we will start. You have probably the majority of you have dialed in via the browser. You can also dial in with audio via phone. You see the phone options here on the right hand side. You will be as an attendee in a muted mode, and you will be able to ask questions in written style via our Q&A panel you may see on the right hand side of your screen. Please use this channel or this panel whenever you have questions during the call. We have a slight delay in audio and video sharing, so just feel free to send a question whenever it comes up, and we are happy to answer these questions at the end of the call. The webinar will be recorded and you will receive it afterwards for your own documentation as well. So this has been the introduction at this point, and now I'm happy to hand over the microphone to Chris, and wish you a good session, and thank you.
Hopefully you can hear me okay, Katrin.
Yeah, Chris, perfect.
Okay, thanks guys. Thank you again everybody for dialing in today. Very much appreciated. Today hopefully we're going to look at some really interesting tools that we've got within our PointSense for Revit plugin. Just to start off, obviously we usually have quite a variety of users in the call, so it's best maybe just to start off with a very quick introduction to what PointSense for Revit is for those who've never used it, and then we'll obviously move on to look at some of the new features and how we can use those. Today we will have some slides, we will have some videos, and we will also do some live demos of the pipe fitting tools later on. So what is PointSense for Revit? PointSense for Revit essentially is the FARO plugin for Revit. At FARO, we have obviously produced laser scanners for a long time, and we recognize that to produce a deliverable from a laser scan can sometimes be a little bit tricky at the back end to produce a 3D model, or at least time consuming. So what we've tried to do is obviously develop this PointSense for Revit plugin, which looks at working with Revit directly inside Revit and extends the functionality of Revit to give us lots of new tools for, as you can see there, easy, precise and fast fitting and geometry creation from the point clouds. Specifically, some of the main features that we've got, and probably some of the best used features, are the automated wall fitting commands and automatic wall alignment tools. So we can very quickly generate a 3D model of a layout of a building very quickly, without much user intuition at all. We can really just create a prepared plan, and we can best fit walls to that plan. What we've also got is some good surface analysis tools. So you can see once you've created your model, you can actually go and check how accurate that is against the point cloud, and give a report, or you've got a legend there, which you can obviously give to your customer or to use for quality assurance for your own purposes. And we can also use these tools for some topographic surface creation and deform shapes to more accurately represent the point cloud itself. As you can see at the bottom there, we've got some good topo surface tools which allow us to do to select points in the point cloud and extend the functionality of what is available inside Revit, specifically directly generating their contours and things from the point cloud. We've also got some 3D construction aids. So you notice there's a small tab showing how we can create reference planes very accurately. This is probably best used for roof construction, particularly when we've got quite complicated roofs. And we can also use point clouds within the family editor. So what we can do is we can take chunks from our point cloud and take them out and put them back into the family template along with some orthographic images. So we can combine really accurate 2D images along with our 3D representation of the point cloud to help us to model up specific elements. In the most recent version, we also have the ability to work with the Revit work sharing tools. So obviously that enables multiple users to use the same central model, and we can work alongside that. Okay, so what's new? PointSense for Revit 17.5. So October this year, we released the latest version of PointSense for Revit, and there are some really good functions that have been included. Obviously, we have compatibility now for Revit 2017, which is the main purpose of these releases. But obviously, we've obviously got some good features to go with that. So the first one will be the Point Cloud Section Manager, which allows us to not just interrogate the point cloud in a lot of detail to isolate certain elements, but also manage the point cloud. So where we have specific elements we want to model, we can save out views and sections and get into the point cloud to look at that a little bit clearer. We also have, which is a really big step towards automating the process, is the modeling of piping systems. So where we have pipe work within a point cloud, previously we've only ever offered this inside our plant plugin for AutoCAD, but now we've actually got these tools natively inside Revit. We also have some improvements in the detail, which we'll look at in a little bit. Okay, so just to cover compatibility there, obviously we're now able to be compatible with Windows 10, and we can support Revit from 2015 to 2017, and it's obviously supporting all Revit versions, so the architecture, structure, MEP, and the full versions that you get from the building design suite. And you can see that we're working directly with the RCS and the RCP point clouds. What we also have, which we'll look at shortly, is our VirtuServe product that goes hand in hand with this plugin, which allows us to view the interface directly, the point clouds directly, and interface with Revit. So we'll look at that as well. Okay, so firstly then, the Point Cloud Section Manager. As you can see there, what we've got is the ability now to define rectangular slices, rectangular crops, box sections and polygons, and also to create some slices from the point cloud. Now, this is specifically important when we're looking at pipe work. Anybody who's modeled lots of pipe work before will know that as things intertwine, it can get very difficult to follow the path of a pipe. So using some of the slicing tools, it is extremely handy to enable us to sort of crop out those areas and follow them along the run and model them as we go. So if we just maybe quick look at this quick video to go through this then. So you can see here what I've got loaded in is a point cloud of a small facility. So I've just opened the section manager there, and as you can see, we get this new pane that is visible on the left-hand side, which we can drag away and undock from the left-hand side there and maybe put it at the top of the screen, or move it back into the side, or merge it with the properties tab. Wherever we want it really, it's just to know that we can actually move that around and edit it. Currently we've got all the points shown, okay, and what I'm just going to do is I'm just going to drop into a plan view and put this side by side with our 3D view so that we can see that everything we do with the sectioning tools carries through into the other views. So it's project specific rather than view specific. If I just go to define a rectangular crop now, and I just load the VirtuServe license in, and I just highlight that box there around this facility, we now get a section name command that comes up, and we can call this a specific name. So we'll call this facility. And as you can see, that's cropped both views in one go. And now at the top left, we have all points with facilities under that, which is the active view. To the bottom, we have these planes, which we can turn on and off, which are the specific cropping planes. So you'll probably notice there, as I turn different cropping planes on and off, the actual the points in that plane become visible again. Obviously, this has got 4 planes because we did a rectangular based crop, but you can see how that's building up into a full crop there. But what we can also do is, obviously, with the structure that we've got on the left hand side, we can build up a hierarchy of cropped regions and work our way down into the point cloud so that we can work in this in a more detailed fashion. So if I go and do another rectangular crop here now, just of the top, and we could maybe call this upper areas. What we can also do is maybe give it a tooltip description just for reference. We could call this top part of the facility. And if we could obviously skip this name if we wanted to, but we're just going to click OK there. You can see that what we've got is obviously the top of the facility. This has been put in the structure tree beneath our facility crop, so we're working beneath that in the structure. And as you can see, these are the additional planes that have been introduced at the bottom. So as the bold text upper areas is active, we double click on facility and make that the active section. Go back to the define rectangular, and we can make a similar section for the lower areas. And because we've activated the facility section, this is going to be done within or below the facility part of the structure manager, section manager. So you can see that there now. If we just navigate around to a sort of isometric view now and have a look into the facility. So now we've been able to get in here. What I can do, I'll just drop down to the top view. I need to just work my way down to look at some of the specific pipe work that we're going to model. So I'm just going to define one more rectangular box now around the target sort of pipe installation. So we'll just give this a name, target pipe installation. And as I save this, you'll notice it does appear beneath the lower areas section of the section manager. But what we can do as we save this, we can actually move this up and down beneath different levels in the hierarchy of the section manager, which essentially allows those planes to be cropped by different areas. So you can see that there now. We've essentially got about 12 planes to create this area. So we could turn some of those on and off. But what we might want to do is maybe just pick that up and drag and drop it beneath the upper areas. And as you can see, that is now the target area is defined by the upper areas overarching section. So you can see we've got a little bit of the tank in the top there. We'll just pull that down. So if we put that back down into the lower areas, and we can maybe look at breaking into this a little bit more detail. So I'll just drop this into a top view and zoom in a little bit. If we want to maybe isolate a specific area, it's sometimes easier to use a polygon selection. So if we go to the define polygon tool, and I'm just literally going to click around the outside of this now to just define the tank. And as we just work our way around, if I just press the escape key, what that's going to do is it's just going to isolate out that tank. We just give that a name, so we'll call this tank. And as we move that around, now that's the active section. You can see there's 13 planes that have been used to define that because I used 13 clicks. But if we drag that up now into the upper areas, you can see again that little section of tank that we had is now visible. And we can drag that back down into the target installation. So we're just cropping out just exactly what we want to have. Okay, cool. So some of the other tools we've got, if we just highlight the target installation and bring that back in, it can be really useful to use the slicing tools to isolate some of this pipe work. So if we go to define slice, we have a window that loads in that will enable us to choose between a parallel or orthogonal slice, and that is going to be parallel to either the XY plane, the YZ plane, or a particular plane or line that we've set up. And we can also choose our slice thickness, or we can define that within the point cloud using 2 clicks. But if we maybe go for a 500mm slice, orthogonal to the X and Y plane, we just zoom in on a specific pipe here. I literally just need to give this 1 click, and that's going to define a plane orthogonal to the X and Y. So we'll call this, just for reference, orthogonal 500mm slice, and we should probably say against the XY, so 2XY. Press OK there. So now you can see just with 1 click we've been able to isolate that pipe and the pipe beneath it as it runs around really accurately within the cloud, which is going to be really helpful for our modeling shortly. So we've got these saved out, but let's say, for example, we go back to target installation and we want to run that as a parallel slice to maybe make a horizontal slice. So again, we'll just go back to that same pipe. I'm going to go to define slice again and just go for a parallel slice. That's parallel to the XY plane. Again, we'll use 500mm. I'll press start there now. Just zoom in, and if I can get a good selection on the point cloud, we'll just rename this for reference again, parallel slice, parallel 500mm to the XY. And that's given us a nice slice through the point cloud now. And remember that all of these slices are editable or viewable, within different views in Revit. So just right click on that there, and I've got a tool to allow me to shift the slice up or down. I've just set that value to 1000mm, so a meter. So if we just press down there now, you can see that's moving the slice down by a meter at a time. So we can work our way through the point cloud in Revit, highlight the areas we want to, crop them down, and save them as areas that we're going to model. So a nice way to manage our information. I've just right clicked there now and gone to add a text file or a text section, which really is a container or a folder. So we add this one now, we call that slices. So target slices of the point cloud. That comes in as a folder, as you can see there now. And what I can then do is obviously just drag those 2 slices into our slice folder so that we can manage our data just that little bit better. Okay. So that's just going to activate now. I'll just zoom out a little bit. The last tool we've got then is to use the section box and to save out specific boxes. So if we just activate the section box tool, which is the standard tool within Revit, we'll just crop out an area of interest using the standard tools. What we can do is, using our defined box, we can save that out within the section manager as something that we might want to go back to. So if I maybe just save out this small component here, zoom in there now, I then just need to go to my define box tool and activate that. We give this a name, so MEP component, and you can see that's loaded there. It's actually below the slices folder. I actually want to move that beneath all points so it's managed a little bit better. So I just drag that up there, and you can see it moves up there. But as I turn off that section box now, you'll see, because that section is active within the section manager, we can still get back to that specific component. There we go. Load that back in. There we are. Okay, brilliant. So that's a section manager. Hopefully you've seen something there that might come in useful. So next we'll move on to one of the new features, which is the load MEP components. Now this is kind of a precursor to doing any of the modeling. We really need to look at getting all of the information available to us that we're going to need to create that model. So as you can see, just in the drop down list within the object tools, there's a new feature there called load MEP components. And what we get from that is the opportunity to choose a source directory. So for example, we go and choose the UK standards, and then what we can do is multi-select or just select specific components that we want the software to search through the folders and batch load the families in. So rather than going one by one and bringing different elbows, searching constantly for the next correct part of MEP, we can batch load things in, use what we need to use, and then if we have anything left over at the end, we can purge the model and take out things that haven't been used. So it's just a quick, again, a way to speed up the process. So just pick up where we left off, kind of, and just go up now to, just go down to show you how the families are loaded currently. So if you go down into your families in a project browser, and we just go to pipes or pipe fittings even, you can probably see exactly what we've got loaded now. So currently we've got a few standard elbows. We've got, if we go to elbow, we've got a standard soldered elbow, a standard plain elbow, which is not going to be much use to us when we come to do our modeling, to be honest with you. So we go back to the PointSense tool now. And first of all, just to show you how we would do this traditionally, if we go to insert and just go to load family, we'd obviously have to go to one specific area within the family and load in that specific family that we wanted to use, which could be quite tedious when you're looking at a large area or a large volume of modeling. So we go to the PointSense tool. Just beneath object tools, then we've got load MEP families. I'll just activate that there now. First of all, we go to the library path. Now I've got that set at UK, but that's going to search through an awful lot of families. So I'm just going to break that down a little bit more and go down to maybe pipe. So we can probably search from the pipe level, or we could even go further down to the pipe fittings level or valves if we knew where it was. If we go to pipe, and then we can specifically choose what we're looking for. So this time we want to use elbows, flanges, maybe the cross sections, some T's, and maybe we bring in some an end cap. There we go. Press OK. You can see now it's looking through the families. Now I will note to you that this is speeded up. This took about 3 minutes for reference. That's about a 3-minute function, speeded up to about 5 seconds. But we've loaded in 141 families. And if we go back down now and look at what we've got a lot more bends and we've got a lot more elbows, different branches and T's, all of the things that are inside the standard UK family components. We've managed to load those in, and then we can start to do some of our modeling. So it's just, again, speeding things up. Okay. So I'll just quickly run through a few slides, and then we'll drop into actual Revit itself, and I'll show you how some of these tools work. So very importantly then, the new main tool we've got, which is really, really interesting for a lot of people, is the ability to best fit pipes to the point cloud. So we've loaded in our components, we've loaded in some piping families, and what we can do now is fast and precisely fit pipes to the point cloud. So what we're doing here now is we're detecting a specific diameter. We've got a rounding value set here to the top, in the top right hand corner. And the point cloud, the software is going to search through all of our loaded types, find the closest matching type, suggest that that's the one we should use. We then need to decide whether or not that's okay, or whether or not we want to insert a selected type with an adjustment. Maybe we model it exactly as it is in the point cloud, or exactly as it has been detected. But 9 times out of 10, I would say people would like to stick to the specific pipe catalogs that they've got, because this is standard components we're using. So we also have the ability there to add insulation to these specific pipes. So if we add insulation, for example, of 35 millimeters, what that's going to do is it's going to give us an overall diameter, including insulation, of that whatever this one was, 180 millimeters. But it's going to give us 35 millimeters radius of insulation around that specific pipe. So it's essentially a smaller pipe with a 35 mil radius of mineral wool, giving us an overall of 180. What we then do, so the process has been broken down really into 3 main issues. We're going to fit the pipes. We're then going to go and we're going to insert pipe fittings. So we're going to do this as a separate function, and then we're going to align all of this together. So once we've got our pipes fitted, we can then go in and we can insert specific components to join these together. And we can do this with an open-ended pipe, or where we have 2 specific pipes in the same run. What we do, obviously, we've loaded in a lot of different pipes. We can go in and select the specific ends of those pipes and find the best fitting component from the list that we've loaded in. Obviously, we're limited to what we can achieve based on what catalogs or what components we have available. But we can do that very accurately, and we can, as you can see at the bottom, use any angle to define that. And once we've done that, we then need to align the pipe run. So you can see probably on the left hand side we have some small gaps between some of the pipes, but what we can do once we run the aligned pipe run tool, that is going to join those together very accurately and very closely. And what it can also do is allow us to speed up the process, because we don't actually have to worry too much about every single pipe joining to the next one. We can run that as a tool at the very end. This is for anybody who uses PointSense for Revit. This is a very similar breakdown in the process that we use with the align walls command in PointSense for Revit. Okay, so if that's okay for everybody, I'll just drop out now into some live demo. So I'm just going to shut this down, go into Revit. So hopefully everybody should be able to see we've got a point cloud loaded in, and I've taken the liberty of creating some existing slices similar to what we've just seen on the videos. So I've got this pipe here which is looking like a carbon steel pipe. We can maybe just drop the section around and you can see how that pipe continues and goes around the corner here. So if we maybe first of all just go back to our horizontal pipe run and just navigate around until we get a good view of this. Very importantly now is the quality of our picks, or the quality of our point selections. Obviously, if I pick an area which is completely incorrect, then the algorithm has no chance of working. So what we do have is the VirtuServe plugin to assist with that, which we'll look at shortly. But also that's why it is specifically important to crop these areas down so we can see what we're modeling. Otherwise, it can be very difficult to make an accurate selection. So if I now just go to PointSense, go to Fit Pipe, I'm just going to go and choose the level. The first thing I need to do is just define which level this is on. So this is on level 0, and it's also prompting us now to select a piping system. So in this specific instance, this is none of the above. So I'm just going to go for other, and I'm just going to go for start fitting. Press the start button. Just going to go in now, make one selection down here, and we're just going to go up to the top and just make another selection here. Okay, so what we should see now on the screen, if I just zoom in, I've currently got a rounding factor set to the nearest 5mm, so it's detected 165 as the closest matching pipe or matching diameter. What I can do is I can just pan around this slightly just to have a look at how well that seems to fit. But also what I've got here is the best fit on the left hand side is telling me that the nominal diameter of 150mm with an outer diameter of 166.1 is the closest matching standard catalog type that I have. So it's actually also telling me I've got a delta error of 1.1mm, which is obviously the best from the bunch. So I can insert this type now and be happy with that and leave it as it is. Or what we could do if we wanted to would be to maybe choose a different size, and we also have the ability to insert that with an adjustment. So if I was to choose a different size, we could go and maybe insert that with an adjustment, and it's going to change the outer diameter to exactly 165. Since it seems we've got a rounding factor, we'll just leave it with the standard type that we've got there. So we just go now and press insert selected type, and now we have one pipe fitted within the point cloud already. So again, as I said, this is broken down now into multiple processes. So we're going to fit these two pipes, and then we're going to look at joining the elbows. So let's go in now and look at this second section. So if we just go and look at this, I go back to fit pipe. Now I have just actually come out of the command, and I don't need to restart it. It will actually run as a series of tasks, but I actually just came out of the command specifically there. So let's go start. Let's go again, click on the point cloud here, and maybe we'll just click on it up here where we can see. Okay, so what we get there is, again, we're getting a 170 rounding, so we're in the region of the same pipe, and from the catalog it's giving us again, it's telling us that this is the closest matching pipe type that we've got in the catalog. So let's go ahead and insert that. Now I understand when people are using Revit MEP, sometimes it's maybe not heavy industries that they're looking at. Maybe it's something a little bit, smaller pipe work, water pipe work, etc., etc. So if we maybe just look at this small pipe down here for now, quickly, part of this is I think it's about a 35mm pipe. But if we just go now and run the tool again, so fit pipe, Same level, I'm just going to click here and here. You can see that there now. It's managed to detect that no problem. And it's actually suggesting the closest matching type we've got, which happens to be copper. We'll just insert that there now. But what we can also do is use our insulation. So if I was to say, add some insulation to this, let's say this had 5 millimeters of insulation on it, or maybe let's go with 10 millimeters of insulation. You can see now if I zoom in, it's actually reduced the size of the pipe and added 10 mil of insulation as a radius all the way around. So obviously you can use that there. You've got to be a little bit careful when you're joining different pipes together if you do use this tool, because obviously the pipe itself has reduced in size. So you need to be conscious of what you're doing as you're working with. Let's just turn that off then. So we're just going to insert a 35 millimeter pipe. And I'm also just going to tick now use hidden parts of the point cloud, because the next thing we're going to do is actually do this same task, but we're going to do it using our VirtuServe side-by-side window tool, which will allow us to take these point selections directly from the point cloud views. So I go and press insert selected type. Okay. You can see that's inserted there now. So let's just quickly load in VirtuServe. So I'm just going to go to my desktop, just load up VirtuServe, and I've got one particular scan loaded in, which was from within this point cloud view. So we just bring in our Revit toolbar, and what I do need to do is just check that this is linked to this particular point cloud. So the first thing I would do then is just go link PC coordinates. It's okay, it's already linked. If not, we would just need to select the point cloud. Just going to click no. And I'm just going to actually activate the fit pipe tool again. This time though, I'm going to make these selections from within VirtuServe. And what we should be able, first of all, sorry, I just need to click the level. There we go, click the level. Go back into VirtuServe, and we should now just be able to make two selections on here and here. You can see the screen's flashing slightly. Obviously, it would be better to have two monitors here now, but it's sending that coordinate to Revit. We go back into Revit, and what we have is this particular pipe. Now, obviously, because we've got that hidden, that part of point cloud hidden, it's not giving us that point cloud overlay, but it is finding the same detected diameter, which we know is correct, so we can select that pipe and insert it. But this is a very handy tool just for running around and quickly inserting pipes, because we could now go and maybe do the same thing again. Let's go fit pipe. Again, just click our start command, and we can maybe finish this pipe off, which might be a little bit slightly difficult to model, and it is quite skewed in the planar view that we've got. We can go maybe up to the top right here, drop that in, and again, it's found that particular pipe, which we can say is okay. Insert selected type. We go back into the main Revit interface, and there we have some pipes modeled up. Okay, so that's good. So what I'm going to just do, I'm just going to drop one more pipe in here now, just so we can do some linking between these elbows. So let's quickly go to our VirtuServe view, navigate around, and we'll just maybe look at this particular pipe here, which joins onto the one we've already modeled. So again, fit pipe, our level, VirtuServe view here and here. Go back through into Revit, and it's finding that same carbon steel pipe, 170 mil it's detecting, so we just insert that there now. So we've got to the point now where we've got some pipes that we can look at modeling up. I'm just going to shut VirtuServe down, and we're just going to look at these pipes here now. So let's hide off the point cloud then for this section. So we've done some pipe work modeling, so we can quickly pull pipe diameters out accurately. But what we might want to do now is look at some of the joins between them. So if we look at this one first, the first thing we're going to do is just go to place a pipe fit in, and I'm just going to select the first and second ends of these pipes and press the escape key. Now you can probably see what that does there now is it gives us a link between these two pipes, which is defined by these green circles, and it's suggesting, or it's looking to the first particular elbow in the list. So because we've obviously loaded in so many of these different types, we can now just search through and look for what is the correct the correct type of elbow. Would it be a butt welded elbow, carbon steel? Probably not, because it obviously has a long radius on it. But if we just move down a little bit, you can see all of these different types we've got. If we were to select maybe a T, let's go and find a T. Okay. What we also get is this toggle button. So because there are multiple ways that this T could be inserted, we can toggle between 1, 2, 3, 4 about how that actually should look. But what we actually do get is this last use types button again. So this is a long radius elbow, so we can just go and select that one there now. Before we insert it, we have this interface down here, which will allow us to use a particular angle. So if I click use any angle, it's actually edited that 90 degrees to be 90.07, which is a lot more accurate in terms of its placement. And we can just pan and zoom around that if we want to maybe just check that we're happy with the fit. So let's go and press OK to that. Okay, so what if we've only got one end of the pipe modeled? I'm just going to bring the point cloud back in this instance, actually. Let's say we want to just model a part of pipe that we haven't got another area to snap to. If I go now and press place pipe fitting, just select one end of the pipe and press the escape key. Again, we can use that same last use type, but what we can do, instead of snapping to this particular end of pipe, we can use a rotation offset and an insert offset. And then we can do this manually, automatically later on using our align pipes tool. So if I go use rotation angle and pick a point in the point cloud, so maybe we just go and select, just navigate across a little bit, just go and select roughly the right orientation. And then what we can do is select an insert offset. So I could do this by a point, or I could do this by text. So maybe if we just do it by a point first, just roughly again to show the tool, it moves it across at the junction. Or we could maybe make this 100 millimeters. Okay, insert that there. And you can see it's got the same orientation, and then it's added 100 millimeter offset. We'll do the same now for these pipes here, and what I'm going to do is I'm going to show you how to join these using the align pipes tool next. So I'll just add one more elbow in here. We've got this quite long run here, so if we maybe go place pipe fitting, select the end of this pipe and the end of this pipe, press the escape key, you can see how that pipe snaps now up to that particular pipe that we created at the top of the building there. And we need to just obviously go down and look for our closest matching or correct pipe elbow, which is probably a CS standard elbow, which is obviously quite difficult to find in the list. Maybe we just select a standard one for now. We'll just go with this one for now. Okay, so you can see it's putting an elbow in, or maybe we put something like that in, which will give us a little bit of a better representation. But you can see how it's joined that there now. So happy with that. Okay, last one I'm going to do then is before we move on to the next part, I'm just going to put one more in here to show how we would join this using the align pipes tool. So go now and place a pipe fit in. I'm just going to do one on the end here. And because we've obviously used that type last, which I couldn't find from the list, unfortunately, just press OK. We've now got one elbow fitted to that part of pipe, which is we would assume would be the correct elbow, and we will look at how we can link that shortly. Okay, so I'm just going to shut this down and open up a separate version of this where I've got a few more pipes modeled. Okay, to this one. Okay, so we've got a few more pipes modeled here as well. So because obviously we've modeled this corner, what we can do is we need to make sure that it's very accurate in terms of its connection. So if I just maybe turn on the wireframe mode, you can probably see there now we've got a very slight misalignment. So what we would need to do then is use the align pipes tool to just join that alignment up. But what we can also do is we can use that to join this elbow to the bottom of this pipe. So go back to our shaded view. Okay, if I go to PointSense and click on align pipes, you'll notice if I select this now, it's turning the pipes blue. It's giving me 4 elements that are selected, and this is all based on the pipe links, on how they are linked. So because we haven't actually physically linked this pipe to this one yet, If we were to press yes now, okay, it runs a small algorithm, and what we should get is a slightly more accurate join on this pipe join here. But we still haven't actually edited this corner yet. So what we can do using the links is use that to help us to join these pipes together. So what we've got here is a tool called set pipe link. So if I go now and set a pipe link between this particular elbow here and this here, this bottom of pipe, you can see we've got now a circle there with a line between them, which is telling us that these two should now within the software join together. These are linked elements. We could do the same with these two here. There. You can see we've now got an additional join where we modeled this corner. It should be joined to the bottom of this pipe. And we could manually put some of these in. So let's say OK to that. Now if I go back and select the Align Pipes tool, we click on that pipe. Now you'll notice it's telling us that we've got 5 elements selected. And if we press yes this time, it's going to pull that elbow into the correct pipe vertices. So it's coming right now against the bottom of that pipe. Do the same here now. So we've got this, which is completely off skew. If we go Align Pipes, because we set that pipe link, notice I select this pipe and everything's turned blue. We've got 5 elements selected, and we go and click yes. So that's very good if you've got small areas that you might want to work on. But what if you've got absolutely loads of pipes that you've modeled up, lots of elbows, and you need to do this with a little bit more or a little bit less user input? So we've got an object here. So if I go Align Pipes on this particular one that we've modeled, you'll notice I've only got 2 elements joined here now. We can also remove links. So if I was to go and remove a pipe link, you notice I've got links here now. I could actually go now and just remove that link. Okay. And if we went down and used that tool now, we would only select 0 elements because we've got nothing linked. So what I'm going to do is I'm going to run the set pipe link auto tool. And what I'm going to do is give it a nice big search radius of 600 millimeters. So if we run this auto link, you'll notice now it finds those additional links between the pipes. It's actually found this one slightly incorrectly, so we'll see what comes from this. But if we go to, oh no, it's just graphical. So let's go and press OK to that. And now if I go to Align Pipes, 5 elements selected, bring that around, you can see it's now joined those together. And if I go and bring the point cloud back in, there we are, we can see that that's actually snapped that all around based on our selections. It's managed to snap that around. So by setting the pipes very accurately, we've enabled the elbows to be snapped into the correct axis using the Align Pipes tool. Okay, great. So just to jump back into the PowerPoint now, one other very small improvement that we've got in the software, just with our heat map tool, there is now lowest grid point selection for the construction point values. So when we're creating our heat maps, we've just got an additional small selection that we can use to generate that map and give us, a low point, a very low point for, for floor flatness and things like that. That's a very small improvement in the detail. I did mention at the start, obviously, all of the features that we've got within PointSense for Revit, but we have got a lot of tutorials online already for these. So if anybody wants to go onto YouTube and search for Qubit TV, FARO GB, or Chris Palmer FARO, you will find some of these videos that I've got shown on the screen there. So all of these are broken down into very detailed videos specific to that particular workflow. And thank you everybody for your participation, and we'll just open up the line for any questions and answers.
Well, thanks, Chris, for this very detailed information and demonstration of the new Revit features. Was great viewing them, and yeah, I guess the MEP experts which have joined us in this meeting are excited to test the new pipe run modeling features soon. I just take a look at the Q&A box right now if we have received some questions here. We had some feedback that the synchronization was not that good. It came not from many people, but I did not disturb the meeting because at my screen it looked fine, and so I guess we will have a good recording for everyone at the end. So there came a question which was directed to us from Kyle. He asked, what file types does VirtuServe work with?
It works with pretty much any scan type, and I might even be able to drop out and show you. But if we go and have a look at VirtuServe, essentially to create a VirtuServe file, we're just importing file types. So if I was to go to create a new project, just put test in here, we can go and import scans, and we can browse, and in our formats there we have a lot of different formats, so pretty much everything that you can think of. A lot anyway. We've got particularly E57. Obviously we prefer to use an ordered FLS would be the best solution for us, but we can also take E57s. We've also got some other formats in there, PTG, PTX, so we've got a lot of different files we can support currently. And that does
Okay.
need to have the same coordinates as your RCS files or your RCP project in order to make the link work correctly. So really don't update your origin in recap if you're going to be using this link. Is this the answer?
Okay, thanks, Chris. Another question came in, which was at least this was mentioned by the attendee, partly answered. It came from Chris, and he asked the point cloud. I think it was at the slide for pipe fitting. There he
Okay.
asked, the point cloud you were working with appears to not have any insulation on the pipe fitting. How does it
Okay.
recognize the fittings or pipe size if they are insulated?
Yeah, hopefully that was covered during the presentation, but just to recap, obviously we are only working with what's visible. So if we have a pipe that's got insulation on it and we've scanned that, we are working to the outer diameter. So we can specify the insulation radius and the size and things like that, but that's not intuitive in terms of it can't see through the insulation to the pipe. It is just a case of obviously using your engineering knowledge to determine what that should be. Which is really the case if you were modeling it in any other way as well. There's no real way to test that unless you either know or you manually check it.
Okay. I think Chris just wrote another information many times. The insulation on pipe fittings, especially larger pipe fittings, the outside diameter or shape around the fitting is far different than the actual diameter or shape of the fitting. Okay.
There's not really a lot that you could do about that, to be honest with you, because
Yeah.
we can't see through the insulation. Unfortunately,
Yeah.
we can only model what we've got visible, because obviously laser scans are line of sight, and that is literally just a limitation of laser scanning. And
Yeah.
to be honest,
Okay. Great. I will just scroll up here if we received any further questions. Um, no, we actually should covered it. Yeah. So let's wait another four to 10 seconds. Or yeah. If you still have a question, please feel free to type it in right now. Otherwise, feel free to contact us after the call. And as Chris pointed to already, we have a lot of recorded YouTube sessions already on our channels. So I really recommend you to have a look on this single sessions as well. If you are not that familiar with the software so far, they really will help you to get covered how the functionality also the first functionality which Chris explained at the beginning, how the features work, and they're really helpful and great material to understand the software's workflow. Yeah, it looks like we have not received any further questions at this point. Yeah, so I want to thank you for your participation as well. A big thanks to you, Chris, as well. I think the attendees have recognized that you have a little cold at the moment, so I really appreciate it that you could manage to provide a session to us today. Um, yeah, thanks again for your attention, and wish you, wherever you will be or wherever you are, wish you a good day or a good night. And yeah, we are looking forward to have you in one of our upcoming webinar sessions again. Thank you very
Thank you very
much.
much. Thank you, guys.
Goodbye. Bye, Chris.